Hello.
Hello.
Good morning, dear friends. I express the great joy of freedom. Wish you a happy Independence Day. I am here to extend a warm welcome to the distinguished guests, participants, the promoters, and the well wishers of the Faculty Development Program organized by the Department of Mechanical Engineering, Jyoti Engineering College, Thrissur, in association with SA India and Kisha Research and Education Trust, Bangalore. This FDP stresses the importance on recent trends in product development. I take this opportunity to introduce you to a renowned personality, Dr. S. Solomon Bobby Selvaraj, Associate Professor, Department of Manufacturing Engineering, Vellore Institute of Technology. Vellore has 20 plus years of experience in teaching and research. He graduated from Madras University, post graduation from VIT University. He has done his PhD in 3D printing from Auckland University, Auckland, New Zealand. He has invented three different material systems to use in 3D printers. The 3D printing lab, which he has developed at VIT, is the first and largest lab in India. He is lauded with National Award by Additive Manufacturing Society of India. He successfully designed and developed a patient-specific 3D printer tailors, the first time in India. He is a soldier of COVID-19 and is in the pandemic battlefield to support and save frontline professionals to control epidemic. Currently, he is involved in number of research projects nationally and internationally. He has to his credit a large number of patents and publications in national and international journals. Without much introduction, we extend warm welcome in the name of this assembly and the prestigious institution of Jyoti Engineering College. The success of this program is the enthusiasm of active participation of the delegates. We extend a warm welcome to all the delegates assembled here. Welcome all. I hand over the session to Dr. Solomon, sir.
Thank you. Yeah, I'm trying to share my screen. Right. All right. No, it's not showing. Okay. Good morning, all of you. I'm trying to share my screen, but I'm facing some glitches here. Someone could help me out, Mr.
Hello, sir.
Yeah, Mr. Praveen, could you help me? Lead me to
Hello,
share my screen. Yeah.
sir. At right bottom, there is an option present now.
Yeah. Yeah. Yeah.
Then click present
Yes.
now. There is three
Yes.
options is there. Select a window.
Yeah. That says that, yeah, window. Yeah.
Then I think your PPT is visible. Some tabs are available. Select a window.
Is that visible?
Yes, sir. It's presenting. Yes, sir. No, sir.
No, no, it's not visible. Yeah, just a minute. Hold on, hold on, hold on. Hold on, hold on. Yeah. I hope my screen is visible to you. Is my screen visible to you all?
Yes, sir.
Okay. Thank you very much for your patient listening. Uh, this, and I would like to thank the organizers of Jyoti Engineering College inviting me to share some of things what the 3D printing can do done for COVID-19. It's my great privilege to be part of this faculty development program organized by the Jyoti Engineering College. And I welcome all the participants. It's a hard time, though we are celebrating our Independence Day. Our mood will be in a holiday. That platform landed in that platform. But anyway, just I won't take much of your time. Just what we have done for COVID-19, or the 3D printing community or the additive manufacturing community did for COVID-19. This is also a kind of a product development and how the chances or opportunities can be used to develop our one product. Just we are going to roughly go through certain products related to the COVID-19. So my first question to you is 3D printing and additive manufacturing are the same or different? I hope you would have come across 5 days this product development faculty development program, and some of our colleagues from VIT would have handled this seminar on basis of the additive manufacturing 3D printing. Just I would like to have some answers from your side. Is the 3D printing and additive manufacturing the same or different? Any one of you, please unmute your phone and please try to answer. Do you think that 3D printing and additive manufacturing are the same or different? Come on, professors.
It's different, sir.
Different.
Yeah, thank you very much. Yes, absolutely, it's a different. Yes, thank you very much. So the 3D printing and additive manufacturing are different, and because of Americans, or you can say that Obama used the word 3D printing. So the media and all the people captured the word is attractive, and they started to call all the additive manufacturing technology as 3D printing. Some of you might be come across this answer. So quickly we will go for the application side of the 3D printing and additive manufacturing. There is no limitations. So, wherever you have a will, wherever you want to have a new design and you want to make your product visible, or you want to see your model in a prototype phase, in a product development cycle, then you will be forced to use 3D printing or additive manufacturing. There is no limitation on application side. Right. Why additive manufacturing for COVID-19? Why not other than additive manufacturing for COVID-19? So the practical scenario, what we have come across in the month of March and April, the answer for these two questions, we practically learned in the month of March and April. During March and April, India and even almost all the countries completely locked down very severely. But later the healthcare professionals facing the problems, and later they realized, the government also realized the shortage of the PPEs, personal protective equipments and the gears, and they're not able to go to the conventional manufacturing industries to open it up and start to manufacture the required safety gears. So the additive manufacturing doesn't require any kind of big industrial setup, doesn't require any the much skilled people, like the people who are working in the lathe machine or any other kind of a CNC machines. So understanding the need of the hour, this rapid manufacturing technology proved to serve the purpose by making the manufacturing and designing process easier and quicker. That is the one we need to understand, designing process easier and quicker. Even we say that CNC manufacturing or other than additive manufacturing capable to produce components, yes, of course, but we need to go for a number of trials and errors before you go for a actual production. But here immediately we can go for a production, and there is no design restrictions if you could use the additive manufacturing. The advantage of additive manufacturing is for a design freedom. Right. So to accelerate the availability of life-saving tools and the PPEs for the frontline workers, the AM community, AM and 3D printing community come up with a lot of innovative designs and time-saving ideas, and that is where the product development comes into play. So wherever the need or whenever the customer looking for a new kind of a product, or whenever the opportunities are given to develop a new product, or whenever the customer wanted a new or entirely different or life-saving kind of a product, then the engineers who are working or the designers that are working on new product development, the platform, their opportunity, they should not miss to address the issues or address the problem in order to make certain products. The first one comes for the PPEs. Again, everybody knows that the facial. Some of you people also would have been practiced and you have printed this kind of or any kind of a face shield. The best part of the additive manufacturing, the community, they developed this type of face shield frames by their own, but without expecting any commercial aspect. They given all the files for a free of cost. All the files were available on an open source. Whoever interested, whoever having a concern over a society, whoever having a concern over the frontline workers, and whoever having a one printer at least, and they can start printing and they can distribute this type of facial to the locals. Okay, locals means the people are in the nearby areas. So the Germany was the company country initiated this PPE production using just a normal FDM process. If you think that it's a manufacturing, then always we think for the big setup or any other sophisticated machines. No, FDM machine is enough to print this type of facial shield frames, and then the shield, it can be either OHP sheets or it can be a polycarbonate sheets, or it can be any transparent sheet, whether it's a biocompatible or not. That is that can be considered in the later stage, because life saving is important than seeing for whether it's a biocompatible or not a biocompatible. So this facial sheet now it's moved to cover the newborns as well. So the importance of the facial has been identified because of the people, the frontline people who are started to get the disease because of the spreading of the coronavirus affecting the every people, especially the frontline people. Now the importance of wearing the face shield on top of the mask were identified as an important gear for the safety aspect. Now they developed this facial from the Germany. Then there are a lot of designs being developed all over. Even in India, so there's a company, the private company started to print the face shields. We know that the FDM is a time-consuming process. It will take a longer time to print one component. So as the same way, the company is 90 minutes taken to print one component, and they're charging 150 to 200 rupees per shield. And really I surprised when I go through this slide. And even I come across while I was working in those 3 months making all these facial shields. So I know what the real cost of the facial, but the people started to yearn and started to steal the money. I could say the word stealing. So this is the best opportunity they utilized. Still they're using it to earn money. Whenever the product is having a cheap price, actually we can give this kind of product less than 70 rupees or less than 60 rupees. On 3D printing environment, the material will be around the cost will be around 30 to 35 rupees, and all these sheets are like OHB sheets only. Okay, the one OHB sheet is around 3 rupees. So maximum 52, yeah, that's all. Maximum 50 should not go. and the people have started to earn money out of the this facial using the big opportunity. Fine. So here you could see the different types of frames. That is where the product development or the design engineers and working on it. Because if you go for this type of red color, this facial, here is the deposition of the material is more, and obviously the time taking to complete the product will be more. Whereas if you see this blue color frame, here the material is deposition is less, the area of the covering is less, so the time taken to print this will be comparatively reduced. Right, there is another company from Coimbatore. They initially they took 4 hours time to print one component, because that is the initial stage. The people will struggle to optimize the process parameters in a slicing software to command the 3D printing machine. And now after the couple of trials, they were able to reduce the time from 4 hours to 1 hour. Right. So the IIT Madras and the people, the students, were initiated this project in association with the next generation 3D printer company from Chennai, and they started to print the facial shield and to distribute to the frontline people, and they charge one mask is around 100 rupees. So look at this frame. This is very simple frame. This frame will take around less than 1 hour, that less than 16 minutes. And it's very easy to assemble, just making a hole on the OHP sheet, just inserting it. And here the back side, you can use any rubber band, or you can use any strap, or whatever available, that you can knot it, and we can give it to the people. So that is a one thing. So there is a concept is, we know that the injection molding, the frame could be manufactured by injection molding. So that during the severe lockdown period, as I told you, the industries were completely locked down, and no possibilities to open up the company using the injection molding. Though the injection molding is the economical way and fastest route to manufacture the components, we can say the products in a mass, but the situation doesn't allow to go for a mass production, though we have a higher, we can say the higher advantages over the injection molding. So the 3D printing community opened up, and they started to print the products. And there is another company from it's called Anatomized 3D. I think it's from Delhi, it seems. So they themselves started to print all this types of masks to save the frontline people. Right. So the school teacher from New Jersey, so he is not an engineer. He's not having any engineering background. Just from his own interest on 3D printing, then the opportunity arose, and he mixed these two, received the opportunity and the interest over the 3D printing, and he started to print whatever the face shields, and started to distribute to the local people. So the interest is very, very important. So then the California, there's a CNSI in the USA again, they adopted the one design, and they will be able to produce 100 to 200 per day with a simple design. So as a design engineer, you always look for the manufacturability. The design, you will be able to design it any attraction with any aesthetic or any up to any level. You may say that my design is a unique one, nobody could design. Yes, of course, we'll agree that. But at the same time, when it comes to the manufacturing capabilities, whether that design could support, or the manufacturing processes, any manufacturing process will be in a position to manufacture certain designs. in this pandemic situation and this the need for an hour, so we cannot go with a sophisticated design. We need to simplify the design in order to print at the earliest to give away the safety gears to the frontline people. So these are some of the more designs. All the designs are available for free of cost. You still, if you are interested, you can go to the websites. I will give you some of the links, free links. Then you can download and start to print and distribute nearby hospital, nearby healthcare professionals. The top right corner, this is the one we adopted. In our 3D printing lab, we have started to print more than 3,000 facial shields out of this design. We felt this design is somewhat comfortable, and there is no piercing of a sheet. Just we can push, and there will be a gap between this frame and outer frame, and we'll just like that we can insert the OHP sheets, and whatever the rubber bands we had, we could purchase, then we knotted in the backside, and we were able to give away this type of face shields to the health work people. So then it was come to the research side, whether how effective the face shields could stop the spread of the virus, or will stop the during the coughing, how much the molecules, we can say, these aerosols could be stopped, everything. So it is a research was carried out sometime ago, and based on this output, or based on the results, they proved that the facial, definitely the graph, the right hand side, shows that it stops the certain limit of the aerosol, the spreading of the disease, using by wearing the face shield. That was about the shield. Then we are moving to a mask. So there was a big shortage at the initial stage of about the N95 mask. And then again, the people were panic. Even the doctors were hesitate to go near to the patients. And the condition was so pathetic in the early March, early April. And then again, the 3D printing community thought, the designers thought, to design a mask which is equivalent to a N95, in order to see the fitment from the nose, jaws, and cheek and chin, the covering everything. And they were successfully, they designed the mask and able to print and started to use it. There are different types of varieties. This mask was introduced by an Italian company, and they used ABS material. Again, they used a simple additive manufacturing process called a FDM, which is equivalent. The FDM machine printed the mask that served the purpose of the N95 mask. Right. This is another interesting mask developed by Silly. And it's very simple. Again, they use the FDM technology only, and here the material is kind of different nano copper filaments used it, because they clinically they say that the copper will attract the disease, and it will not leave the it will not enhance the spreading. It will suppress the viruses and bacteria. So the 3D printer able to print all the parts shown in the picture and be able to assemble it. Initially, the product, the mask, will be printed in this manner. It's like a flat, and using hot water or the hair dryer with the temperature of around 65 degrees centigrade. So just you can apply over it, and you can bend it to the correct fitment of our face, the person to person. the two sides, and this side is covers the nose side, and all these filters we can put it inside in the area where it is available. The fitment is somewhat, almost we can say it's a perfect fitment for a individual users. This is another company from Switzerland. they come up with the soft material, a kind of a TPU 95A material, which can be a washable and reusable kind of stuff. Again, they developed this design, and they printed completely all the parts by FDM again. So you no need to look for a commercial additive manufacturing machine, which is a little costlier than the FDM machine. Just using tabletop or just using the desktop printer, we will be in a position to print all these components to parrot. Then for the next level, the same company, they produced the mold and used the ABS filament to make a mold. And once the mold is like in our investment casting process, so the mold is ready, and the silicone rubber will be poured into it. And after the curing, they were able to remove the mold, and silicone rubber mask was taken out. If you like to download the file for of this, or you want to make a mold out of your ABS or any other material, if you look for a file, you can visit this site, and you will be able to download for free of cost. Right. So the Sharon, that is called the company, or we can say it's the what is that? There is a atomic regulation that agency. I'll try to tell you the exact name. It's in French, and they developed these products, these two products, and they're in the office, or you can say it's there in the unit. They successfully able to make the mold, and injected the silicon manually, and they even tested it during the test condition. And another company from USA used the selective laser sintering SLS process to print the another type of a mask. So here is kind of a flexible and a thin wall section, which can closely fit with the shape of a face of the individual person. And they one step ahead. They tested it for the real time, and how the other masks or N95 masks are being tested it by spraying the kind of sweetness, some spraying some other tasty stuff, and if the person is not able to feel the taste, not able to taste the whatever the taste is spread over his nose, and then the product is completely standardized one. So it's kind of biomedical equipments. You can say if the user is not able to see or not able to feel any taste, then it's completely standardized product. So apart from that, it is this product goes for a number of other trials. I mean, involving a breathing test, then the movement of the heads, shaking of the heads, even speaking. The speaking should how comfort the person to speak. All the tests are mandatory, and they particularly this design passed all the standards, all the tests. This is another interesting one. Again, they used FDM technology, and they used TPU soft material. This was developed by Spain, and this is very comfortable. And if you see that this is the print direction, and they claim that without any support structure, without any developed support structure, they will be able to print this part. So if you like to download this type of mask to be printed at your lab or office, then you can please visit this site, and you will be able to download the files for free of cost. Another interesting one in Italy happened. This is the kind of scuba mask being used, or it's been used practically. Okay, but what did they do? They made this scuba, the facial shield, into a ventilator mask. The engineers from a company, they designed this yellow color ventilator and they're attached into the scuba existing design. So that's why the product development, it doesn't always look for a new product. It looks for the opportunity to rework or modify from the existing design, just to adopt a small design variation externally and attach with the existing one to convert as a new product. They will be successfully there able to come up with this ventilator mask, and it's a welcoming ventilator mask for the people who are in a severe condition of the COVID-19. So what the general practice of ventilators given to the patients is, so they'll fit into the nose, they will fit into the mouth, based on the condition of the patient. That is a painful situation when they're inserting this kind of parts into the mouth or the nose. But here that problem is completely avoided. The inserted are fixed on the top, and the oxygen supply is through this part. This is kind of a comfort. It gives the comfort to the patients. Yeah, there are different types of venturi valve. There is a shortage of venturi valves again in Italy, and here the left hand side is the regular manufacturing method, or you can say conventional. This was produced by a conventional manufacturing method. You may be saying the injection molding, of course, and the shortage was during that time, and they approached again the 3D printing community, and this was happened again in Italy, and they are able to print the prototype by reverse engineering concept by FDM. So they developed the STL file, and then when go for a mass production, when the need of the part was huge in number, then they adopted the SLS technology, the powder based SLS, and they started to print number of venturi valves and to meet the requirement. Again, if you like to download and print one or two components like this, then you can visit this site and you'll be able to get this STL file for free of cost again. There are different types of venturi valves to control the flow of the oxygen, whether it varies from 40% the 42 lbm to 120 lbm based on the requirement and based on the condition of the patient. So we can use the particular venturi valves. Yeah. So the next one is called a circuit splitter. Here you could see, yeah, one machine typically are in a medical condition, one machine for one patient. But the countries face the problem of shortage of the ventilator machines for the number of patients. So again, the people have come up with the idea of having a one machine and having a splitter, so that the two people, the two patients can be given the oxygen. So this is a way that it can be connected, and the two inputs and the two outputs. That is possible by this machine. So they used any available materials, PEG or PP or PLA. But the thing is, the 100% infill, there should not be any micro or any porosity, so that the leaking of the oxygen or the leaking of the carbon dioxide will be avoided. Again, they use the FDM technology. If you like to know more about this, or if you want to print anything, just you can visit this site and you can download the files to print. Yeah. Another interesting one, I'm amazed seeing that no electricity ventilator. So again, they used the FDM printer, and there's a replicator machine. They used it. It was developed in USA, and they will be successfully developed it, and they started to use for a power failure condition. So it happened in India also, right? Some time ago, there were some issues in power and the child ward, and because of that, the almost some 20 plus child were died because of the oxygen deficiency kind of stuff. So this type of ventilator, no electricity ventilator, can withstand up to 24 hours. Right. The next one is test swab. This is where the country should focus on it. I can say, without testing, we cannot say that this many number of deceased people in this country, these many people are recovered, or these many people not affected. The percentage we can say without testing it. So the test swabs again were in a shortage, where they were in a panic and they don't have any the safest test swabs to go near to the patient and to take the samples. Again, the Spain came up with a very good idea with the test producing, design the test swabs, and they will be able to manufacture again 324 swabs in 11 hours, which translated in the 24 hours, they were able to produce 650 from a machine per day. So if you have number of machines, then the quantity, the number of swabs will be increases. They used DLP system and SLA system, stereolithography. This is what the USA company, again, they were able to print 1 lakh test swabs from a Form Lab company. It's a well-known industry, 3D printing company. Form Labs good in developing the machines and manufacturing machines for SLA and DLP systems. So this is the way the designers given a different design in the tip where to get the fluids for a testing purpose. Again, the design engineers played a vital role in designing, because we need to have certain amount of the fluids for the testing purpose. So the test swab dimensions was given, it's like 150 mm and 8 diameter is 3.8 mm. All these crucial dimensions. Okay, you can see it's a neck diameter of 1.5 mm. Compared with the FDM process, FDM is quite capable, but SLS, SLA, and DLP system is much ahead in producing thinner sections. There is the Form Lab claims that their printers can print the part with the thickness of 1/4 of the human hair. So that much accuracy their printers could give it. So they adopted this Form Lab, the SLA concept, to print all these test swabs. Again, the Switzerland armed forces, they also come up using the DLP machine. Here is a DLP machine, and they started to print the test swabs for their country. What's happening in India? There anything happens in India? Yes. So recently, just 2 months, not even 2 months, it's a 1 month ago, India come up with this test swabs. So it's a common, it's the work or the tri-party work, I could say. The Center for Materials for Electronics Technology, CMET, headed by Dr. Milan Gulkani, and Additive Manufacturing Society of India, President Dr. Jyotish Kumar, and with the support from Dr. Sridhar from Rangadore Hospital, Bangalore. These 3 people sat together and designed these test swabs, and with much cheaper price. It says 1 rupee 65 paise, it seems, if I'm right, if I could remember correctly. And the quality is equivalent to the commercially available test swabs. This is the first time in India started to produce or manufacture the test swabs. Till then, the entire India were dependent on a Chinese or a South Korea to get this type of swabs. And this swab also meeting the standard of having a length of 150 centimeter, and it's kind of no nasopreil gel at 7.5 centimeter. You can see here there is a break point, so that this is easily to break it. It should not be take it out for an entire length of 150 mm. So the portion, the head, we can say, which is having a fluid, it can be put in test tubes for the testing it. So now it's starting. Now they are printing in a mass production in Bangalore. So the other PPs from 3D printer, it's kind of safety keys, different types of safety keys in order to avoid touching of the metal doors. You know that the coronavirus will live on this metal surface for 24 hours. To avoid the contact, then they will start to use this safety keys and gloves remover for the healthcare people, and sanitizer dispenser against a 3D printer, and the another door opener, elbow operated door handles, this kind of stuff. All the keys being developed by an Australian company, and again they're given for a open source for free of cost. Anybody can download, even all the four. Anybody can download. You can make use of it in order to control the spread of this coronavirus. Right. So if you're wearing a long time the mask, the backside of the ears will get hurt. Okay, so then we will be seeing that kind of a itching or kind of a painful situation. To avoid, because the healthcare people should wear for 8 hours to 10 hours continuously the mask, to make them to comfort of wearing that, and in order to avoid the itching of the backside or paining of the backside of the ear. Actually, it's a school student from USA come up with this buckle concept, but immediately the Creality, the Chinese company, adopted this concept and started to print this simple buckle and where the mask rope or the elastic can be attached into it and can be worn for a longer time in order to give the comfort to the people. Right. How to reduce the print time? That is a big challenge in front of the 3D printing experts. So the couple of parameters I would like to consider here. Please remember, there are n number of parameters to be considered. Just I have taken a few of them. The first one is if you are looking for if you are using a FDM technology, then layer height is the important one. It can be varied from 0.1 to 0.3 for the simple machine. There are machines you can print with a 0.05 as well. But for just for the common scenario, I have taken the layer height is 0.1 to 0.3 mm. By varying the layer height, we can reduce the time. And the second one is infill density. The infill density could vary from 10% to 100%. More the infill density, more the time. Less the layer height, more printing time. A print speed 10 to 150 mm per second. Again, it's the influencing factor of increasing or decreasing the print time of a part. And the travel speed, when the nozzle is not deposits, when it's moving from one, after completing a one layer and moving to the start point to print the another layer, that idle movement condition, we can vary the speed. Again, we can modify the print speed. So what is the need in India? It is, this census says up to June. I don't know what is it, increased or decreased. And there are 27 million N95 masks is required. 15 million, the entire PPs, what we have seen so far, the face shield, mask, and the venturies and all other stuff required for 15 million PPs. And 1.6 million diagnostic test kits are needed for India, and 50,000 ventilators are needed. Out of 50,000, and they're saying that 60,000 are available and ordered for 34,000 ventilators. We don't know when is the delivery schedule or when is the delivery time to give the 34 ventilators. Please, here, diagnostic test kits. Here is the one I'm not happy with the Indian government. They're saying that's 1.6 million. 1 million is how many? How many? If you convert into lakhs, how much it will be? So 1 million is 10 lakhs. So only 16 lakhs diagnostic test kit is required. So we have more than 130 crore people, but they're looking for only the 16 lakhs diagnostic test kits. So each and every person in India must be tested. Then only we can get rid of this coronavirus. If you are not testing the 100%, we cannot say that India is much agar or India is doing a super work in controlling the coronavirus. All this blah blah stuff should be stopped unless otherwise tested 100% of the people in the country cannot claim that they are controlled the spreading of the coronavirus and they are free from this much, all this blah blah stuff. The so-called advertisement must be stopped. For example, for the last 102 days, New Zealand was free from corona, and they yesterday only they found 4 people got this virus because of the people who migrated. Still, the flights are going to New Zealand, and the people who that also see understand that 4 people from India. So recently they landed Auckland, and they've tested it. Their case is positive. Because of them, now the Auckland has been again locked for another 1 week. So the entire New Zealand, they tested it, and now they declared that the New Zealand is free from corona. And because of the migrant people of a 4, and now recently found that the virus, the spread of the community spread is in the Auckland state. So unless we completely test, we cannot say we are free from or not free from that. So the government has to look into this aspect. Right. So what we did as the Additive Management Society of VIT student chapter, so I am the coordinator for the student chapter, and we adopted in the early of March. We have taken all the free source files and we started to print the shields, splitters, ventilator splitters, flow control, oxygen flow controllers, and more than 3,000 gears, personal protective gears printed at our lab. Only 2 people, it is myself and my colleague, only the 2 people. We worked for almost 3 months continuously, including Sunday, in order to save our frontline people. So all the gears we printed and we given for a free of cost to the healthcare people. We almost covered the entire Vellore district where the college is located, and still the orders have been coming to us, and we are trying to meet the requirement. Understand? Here you may say that, sir, what is this kind of rope you are saying? That time, the March month, I don't know whether you people will believe it or not. Early morning, 4:30 or 5 o'clock, I will call some of the shop people to come and open the shop to give some material. Even the watch piece, we could not get it. Even this rope, we could not get it. If you could remember my first slide, introduction slide, where I shown one shield, that you could have seen, I don't know how many of you noticed it, the red color band is like kind of a friendship band. We bought a friendship band and just we stapled it to make it as a band, we stuck it to the back side. The material availability was so badly. We experienced a bad condition and worst condition. Even a one stapler pin, we could not get it. In that scenario, whatever the materials were available, then we made use of it to make the face shield and other equipments in order to save our own people who are in the front line. Right. So far, we have seen that the parts produced for COVID-19 scenario. So another two slides I wanted to tell you what we have done using additive manufacturing in the general medical application. This is a very interesting one. Is here, this is called a bolus. You could see. This is a bolus. You can say now the seeing the picture itself, you'll be able to understand. This is a part produced to enhance the treatment of the radiation to the cancer patient. So this is our 3D printed bolus. So the problem what happening is the conventional bolus. This is called a bolus. Conventional bolus having a gap between a skin and the part. So because of that gap, the radiation, whatever the radiation been given, that will scatter around the body. Because of that, the people's skin is get burned and you could see the black in color. If you could see some of the patients having a black in color because of the radiation, that is because of the gap between the part and the body. So they come up to avoid this kind of problem. So the CT scan was given and we extracted the CT scan image and we designed this bolus model with a normal PLA, and again we printed with the FDM machine. And you may ask, what is this is kind of a zigzag. The part is more than our build volume, build surface of our machine. So we split this into two half and we made it as a watertight fit, and all this been fitted, and they could see now the scattering of the radiation is much reduced when compared with conventionally manufactured the bolus being used for treating the cancer patient. The another one is it's a recent one, very recent, just 3 months, just before the lockdown started, we completed this project. This is very interesting one. So here a patient lost the talar bone, which connects the upper bone, and here this side of the bone and this side of the heel side, which is the pivot point to move our foot in the direction, and it enhances the walking capabilities on stable condition. So unfortunately, the patient lost that bone, and his bad time again. When he met with an accident, that bone came out, and by his fate, there is a dog nearby, and the dog took away that bone. He could not receive it back. So since he is a 23-year-old boy, so the doctors felt very sad on him, and they thought to make him to walk, even if not for a running. At least the boy should walk. So again, they approached us. Then we have taken the CT image of the broken one and the good one, and then we mirror image and of the good one, and we could get this type of bone. And from this shape, we developed the bone, the part like this. And there are a number of iterations we made it. And finally, we come to the conclusion that this type of model will be suitable. And because we referred a publication which was published in some last year, December, from other country, then we come up with this particular design. And then we made again, FDM was used to make the prototype in order to see the fitment exactly to the broken area, the damaged area. And we are able to see the fitment and the correctness and number of iterations we made it, and finally we got the confirmation from the team of doctors and to go with this model, this design. And we printed the upper part. We split it actually, lower part and upper part. This is the lower part printed with the titanium Ti64, and this is the upper part is a ultra high molecular weight polyethylene was used. This is a biocompatible material, the polyethylene, and we used to make the top part, and then it was assembled nicely. And the next picture I'm going to show you may be a disturbing for some of the viewers. Please bear with me because I want to show you the real condition. So successfully it got operated, and now the patient is able to walk. This is the way we are done for the real-time environment. And thank you for your patient listening. And that's all from my side. Now the forum is open to ask questions if you have.
Any questions?
Yeah, please. Any questions, please? I'm ready to answer. Yeah, fine. So there is a question now comes for a FDM for a dental application. Yeah, it's of course. Yeah, we can use it. The material is called peak material, polyether ether ketone. Can be printed by using FDM machine in order to make some crowns or to make some dental parts. Yes, of course, we can use FDM, but the material must be a peak material. But there is a challenge in printing peak material using FDM. But we need to maintain three temperatures. One is the melting temperature of the filament, and a bed temperature and surrounding temperature. So the normal FDM printers cannot be used it. That means open FDM machine cannot be used. The closed FDM machines could be used to print peak material for dental applications. Yes. So okay, let me go through the chat box if you have raised any questions. Yeah, the question is difference between 3D printing and additive manufacturing. Yes. So the 3D printing, the technology which imitates the office printer. So what is the office? How the office printer works? So the paper is being fed, and on the paper there is a ink, right? The ink is gets spreaded on the paper. The technology which imitates the office printer using the liquid binder, which can spread it through a print head on the surface of the, whether it's a metal powder or polymer or a composites, that is called a 3D printing. Additive manufacturing, the rest of the technologies will be called as additive manufacturing, which stick the layer by layer by extruding the polymers like a FDM, or by using the laser or electron beam as an energy source to sinter it or to melt the powders. All right. What are the other questions? Let me go through. All right. Yeah, I will share my screen. I will give it to Professor Praveen, and he will share you. Yes. Yes, answer. How can get outcome for this? What is the special features takes place in N95 mask compared than other type of mask? So the 95 in the sense the confidence level, or you can say the filtration percentage is 95%. The spread of the virus or the bacteria will be 95% will be arrested. That what is mentioned as a 95%. Whatever the mask we are producing it, if could meet the standard of controlling 95 or more than that, we can adopt those designs for medical applications. Yeah, application of jewelry making. Yeah, you can use FDM machines for prototype development, and you can use the wax printers for a jewelry application. So the wax printers will be used to make the wax patterns, and then then rest of the things is like following the investment casting route. So we can make a slurry around the wax pattern, and then when it de-waxed, we'll be getting them cavity, and inside the cavity you can pour whatever the gold or silver into it, and we will be get it. That's the one route. The other route, how the 3D printing is now been used to make cake, I mean to burger or pizzas, and same way there is a company in Coimbatore. There's a big jewelry company. They're using 3D printers to make jewels in order to avoid the wastage. Wastage is a big cheating by the jewelry shops. Still, the people in the Coimbatore, they adopted 3D printing technology. Like again, it's a wire-based, FDM-based technology, FDM-based filament. The gold filament will be sent to them, sent to the machine, and the machine started to print exactly what design the ornament is supposed to have it. Any journals for 3D printing? Yeah, there are a number of journals, 3D printing journals, additive manufacturing journals. It's available. You can Google it. You can easily get it. Right. Any more questions? Any biocompatible materials for external organs? External organs. Usually, biocompatible material will look for internal organs. External organs means, yeah, again, the peak material is kind of biocompatible material in the polymer side. If it is in the metal side, cobalt chrome, titanium 64 alloy, or even a magnesium, it's all biocompatible material. Malavika Venkata is asking both are layer to layer only. What is it? I couldn't get that. Layer to layer. Right. Let me see. Is there any other questions raised? So the other material I could say the gypsum salt, gypsum-based salt to make the bone. That's also another biocompatible material. So maximum hardness, someone is asking, maximum hardness material for 3D printing used. Okay. The strength, we can say in strength, hardness, tensile, compressive, all the strength is, we can consider it. The strength will differ from material to material. If you are looking for a polymer, if you are using a polymer material, it will have some different strength. And when you look for a metal, and it has a different strength. So as per the ASTM standard F42 committee, they described the strength to use it for different applications. Yes, of course, there is a strength criteria of 3D printed materials. So for example, if you wanted to know the example of the material, ABS is the suitable material, or nylon 12 is the best material which can give a equal toughness to the aluminum component. So nylon 12. Any restrictions of material not used in RP method? As of now, the additive manufacturing community facing a shortage of the material. There are vast openings for researchers to invent new materials for different additive manufacturing machines. There's no restriction in using any material, any other material. Mr. Sinivasan is asking, in Coimbatore, tell the 3D printing machines using companies. Okay, there is a I shown in slides also. The company is producing a face shields. While sharing my PPT, you can find out the company is using FDM machine producing the facial shield. So someone is asking viscous hardness and Brinell hardness. Of course, I have a no exact value, but the hardness values varies based on the different print condition. It depends upon the process print parameters, and it depends upon the nature of the material, and depends upon the nature of the machine. Whether the polymer are looking for a particular polymer, among the polymers, for example, PLA will have a different hardness, ABS will have a different hardness, nylon 12 will have a different hardness. So we cannot bring out the common values for a 3D printing components. Yeah, Augment 3D is from Coimbatore. Thank you. So is there any other questions to be answered? You are welcome. Any more questions? I could not see anything in the chat box. So there is no maximum Brinell hardness number. That's what I told you. That depends upon the process parameters. See, for example, if you are using a FDM machine, the 20 infill density, if you use a 20 infill density, that will give the lower limit, lower value. If you are using a 95, but I'm not saying 100% infill, 95% will give you the highest density value. Any advanced technology is available in the market as same to? Yes. Especially in advanced technology, I can say hybrid additive manufacturing. Hybrid additive manufacturing means adopted the additive manufacturing and the conventional manufacturing. That is called a hybrid manufacturing. For example, the additive manufacturing, there is a SLM technology, selective laser melting, which can produce the parts out of the metal powders. Okay, that will have a least surface quality and the dimensional accuracy. In order to increase the dimensional accuracy and the surface quality, now the hybrid additive manufacturing adopted the small micro milling cutter. Once the 2 or 3 layer is being deposited by SLM technology, and the milling cutter will get encased and it will go over the printed solidified layers, and it will trim off the layers, so that the dimensional accuracy and the surface quality will be improved. That is called hybrid additive manufacturing. Right. So, any other doubts or questions? Yeah, can we? Of course, please, I request you all professors, please introduce 3D printing. This is the life for our youngest generation. Please introduce 3D printing, and if possible, in your college, please buy at least one 3D printer, which costs around 20,000 rupees only. The minimum is 20,000 rupees. So that you can buy and introduce the machine and let them play using that machine, and please teach the 3D printing. The next 30 years, this is going to be ruling the entire manufacturing sector around the globe. Please. And if you want any help in setting up the lab or finding the good machine and how to use the material, how to set the process parameters, and if anything related to the 3D printing, please don't hesitate to call me or ping me or to email me. I'm ready to help you out. Please. Yeah, what software is all so far we are using a free software like a Cura or number of 3D printing softwares available for free of cost. In our lab, we are using almost free of software only, except for a metal printer. We are using a licensed software because the machine came up with the inbuilt software. That cost of the machine is 1.5 crore. It's a metal printer. For other SLS, SLA, FDM, we use free softwares only. So any suggestions for software related means first you can download your Cura software that will lead you completely, and it's kind of user friendly software, and then you can get it from Google easily. Cura. And one more thing I wanted to say here, the modeling software, you people may be practicing it, or some of you may be good in using that modeling software. Please try to use Autodesk Fusion 360. It has a number of features, and the student version is available. Or even if you could register with your official college ID, they will give you the full module for free of cost for 1 year. Okay, my email ID and contact number, I will type it in the chat. You can see it. You can take it. Right. My phone number is yeah, given my email ID and a phone number. Please, you're welcome to ask doubts related to 3D printing. Or even if you are planning for any students' projects, especially the final year students looking for projects. And if you are interested to work in 3D printing projects, even if you don't have any facilities, even if you don't have any machine, and even if you don't have any the prior knowledge or information, please talk to me. I will frame some of the projects for you. That project you can give it to your students, let your student work. Even if possible, you can send me a design. We will print at our lab and we'll send you back the components, and I will tell you what are the tests to be conducted. I will share the process parameters, and then test can be carried out. For example, tensile strength or compressive strength, surface quality measurements, everything you can done at your lab, and you can the students can finish the projects, and you can go for some publication with the simple journals. I can help you out. Yes, yes, yeah. Thank you, Mr. Shanmugapriyan. Yeah, Mr. I know Professor Sugavaneshwaran. We are sitting next to each other. So, any other doubts, please? Yeah, you can ask also.
Any other questions? Okay, thank you. Respected Dr. Solomon sir and friends, the session delivered by Dr. Solomon sir was exploring the details of nutrients in medical assistance in the pandemic scenario. I take this opportunity to express our gratitude to the resource person. As a token of love and gratitude, I request this eminent personality to accept our sincere words of thank you. Thank you, dear sir.
Thank you very much.
Also, we express a word of thank you to all the delegates of this session. Thank you very much. Tomorrow's session will be handled by Mr. C. Karnagaran from VIT Vellore at 11 a.m. Thank you all. Jai Hind.
Bye.
ऐसा फीडबैक लिंक